All right, so when we're writing formulas for quadratic functions, one of the main things we need to do is find important piece of information. So if we look at this graph in particular, if I wanted to write the formula for this function, what I first need to do is look at the y-intercept and then the x-intercepts. If I have all those pieces, this is going to be relatively simple. I know that I can write this in two different forms. I can use standard form or factored form. Factored form is easier when you have your zeros. So my factored form to start off with would just be y equals a mystery value a. I don't know what a is yet, but I do know that the graph goes through 1 and 3, so x minus 1 and x minus 3 are the factors that go with that. So now all I need to do is use this information. I have to use my y-intercept and then get a value for a. So I know this point is actually 0, 6 if I were to write it in a coordinate pair. And if that's 0, 6, that means that when x is 0, y is 6. And if I take the time to go through this, that's going to be times -1 and times -3. So this is going to be 3a equals 6. So I know a equals 2. So I can write this in factored form now. Y equals 2 times x minus 1 and x minus 3. And if the directions either don't say or if they say specifically to write in factored form, then this is where you can go to. Let's just stop right there. Now, if it says to write it in standard form, well, then we're going to multiply this out. So I'm going to leave the 2 there for a second and multiply these two, x minus 1 times x minus 3. I'm going to get x squared minus 4x plus 3. And then multiply that out, 2x squared minus 8x plus 6. Okay, so either this will be my final answer, this is factored form, or this will be my answer, and this is standard form. Okay. Now, some things to note. All points on this parabola are symmetrical, or have a symmetric partner. So 1 and 3 are the same distance away from what we call the axis of symmetry. All right, so the axis of symmetry is going to be directly between those two, which means it's actually at 2. I don't necessarily need to have a y-intercept in order to do this process. I could have any point. So if I knew that this, there's a point here, I don't even know what that would be, but let's say it's like 4, 2 or 3 or something like that. We'll do 4, 3. All right, I should be able to use 4 for x and 3 for y the same way I did here and still come up with the same a value. So it's not restricted to just having a y-intercept.